So we're gonna work on something called dilations today, and I made them full page just because you guys are gonna be drawing the dilations on graphs. I thought maybe this would be easier. So, as I was saying, today we're gonna go over dilations. I do have rulers too. Not sure that you really have to use those. But in some cases it may be helpful. Let's see if I have enough. I don't actually. So if anyone thinks they won't use one, maybe you could hand it over to that last row. So yeah, otherwise you'll just have to kind of sketch it. All right, so like I said, we're gonna be working on dilations, and a dilation is a type of transformation, just like we did way back in chapter 1. We talked about reflections, rotations, and translations, and you did those in middle school also. But dilations is another type, and very likely you did dilations back in middle school also, okay? So when we look at a dilation, we need to know two things. One thing we need to know is what is the center at which your dilation is going to be about. And then you also need to know what the scale factor is. And in this one, the scale factor is 2.5, okay? When you do a dilation, what happens is, if you did it on graph paper, and I skipped this part, but if you don't do it on graph paper, what you would do is draw a line from your center to a point on that first figure that you're dilating. And then if your scale factor is bigger than 1, your new image is going to be bigger than your original image. And one of the things you'll see today is they call the original figure your pre-image, and they'll call the new figure just your image, okay? So if you were doing this just on paper, you didn't have a coordinate plane, you would use a ruler to measure from C to L, and then you would multiply that by 2.5. Like here, if you measured from C to P, they're saying that's 4. So then when they went to figure out where is P prime, they would go 4 times 2.5, which is 10, and then they would draw this so that this is 10, okay? I skipped those, and we're doing ours just on coordinate planes, so you don't have to use a ruler and things like that. So here's just an example. If your scale factor is bigger than 1, the hot pink triangle here would be your pre-image, and then your new image, which is the lighter color, that one's going to be your image, and it's going to be bigger if your scale factor is 2, it's going to be smaller. And how they describe this, K is what they use for scale factor. And if your K is between 0 and 1, that means your figure is going to be reduced or smaller, okay? So the hot pink is your pre-image, the lighter one is your image, okay? Then, if we look, another thing I wanted to explain is these dilations are not only transformations, they're also similar figures. So if you took this scenario right here, okay, and you found angle A and angle A prime, they would be the same. If you did B and B prime, those would be the same. And if you did C and C prime, those would be congruent, okay? So they're similar because the angles are going to be congruent, the corresponding angles. But then also, if you checked from your center to A prime, and then did the measurement from your center to A, and you did that as a scale factor, and then you checked, okay, this time I want to go O to my C prime over my O to my C, this ratio and this ratio would be the same, which in this case they're saying it's 1/2. And you could have also done O to B prime over O to B, and that would also be that same scale factor, okay? Because the corresponding angles are congruent and the corresponding sides have that same scale factor, that makes these two figures similar, and that's why it fits into this chapter. Now I kind of talked about this already, but they use K for the scale factor. If K is ever bigger than 1, that means your dilation is going to produce a bigger figure. If your K is between 0 and 1, that means that your figure is going to get smaller. And then if K equals 1, that means your figure doesn't change at all. So if you had a scale factor of 1, your pre-image and your image would be the same thing, okay? These are just a couple things about dilations. The orientation of your figure stays the same, so it shouldn't be turned or flipped or anything like that. The corresponding angle measures are going to be congruent, and then like I said, the two figures would be similar. This is showing, another thing I didn't talk about yet is your pre-image is just going to have normal letters for the points. So like A, B, C, D, your image is going to have primes by each of them. So this point right here is A prime, B prime, C prime, and D prime. So that's going to be your new figure. When your K is between 0 and 1, notice the green image is smaller. If your K is bigger than 1, your green image is larger. If K was equal to 1, it would just be the same figure, so it wouldn't change. One last thing we need to know going in is that you're going to get points today on your coordinate plane for everything. So let's say that you had this triangle on a coordinate plane, and let's say this point right here was 6, -1, and you knew that your K, your scale factor was 0.5, okay? How you determine what your new points are is you just take your K and multiply it by the X coordinate, and you take your K and multiply it by the Y coordinate. So it was 6, 1, I would just do 6 times 0.5 for my X, and -1 times 0.5 for my Y. You do not have to show that. And half of 6 is 3, half of negative 1, I'll just write it as either negative 1/2 or negative 0.5. Okay? So that we'll be doing today again. This I kind of already talked about. Congruent, your K would be 1. Reduction, K would be between 0 and 1. And enlargement, K would be bigger than 1. And then this down here, you really don't have to worry about. But if you did ever need to find K, you would take the distance from your center to one of the points on that first oh, no, I'm lying. My pre-image is actually the orange. Okay, so what you would do, this right here in green, that would be my pre-image length. And in blue, that would be my image length. And to find K, I would take the distance from my center to my image on one of those sides and put that on top, the distance from my center to one of the points that's corresponding for the pre-image length, and I'd reduce that as a fraction. If it's not a fraction, I would put it as a decimal. Okay? All right. So this is what it is going to look like today. I'm going to be giving you points. We're going to plot them on a graph, and then I'll tell you what our K is. In our situations, I made it so that all the time our center is the origin, because that makes it easier. Okay, and then you're going to plot your first figure, and then you're going to take the points of that, and you're going to multiply every x and y by k, and that will give you your new points. Okay, so let's try one of these. The first thing that I do is I copy this down here. So you have to say J is negative 2, 0, K is 2, 4, L is 8, 0, and M is 2, negative 4. Again, we're always dilating about the origin, and one of the things they want us to do here is say, is this one going to be an enlarged figure or a reduced figure? Reduced because it's less than 1. Very good. The other thing that we have to do is, there should be an arrow here actually, is we would write what's called they'll say like, what's the rule for the dilation? And that's just where you take your K and you can write it as a decimal or a fraction. And I tend to like decimals, so I'm going to go, you'd go 0.75 times every x and 0.7 times 5 times every y. So this is another answer. Okay. And then what I'm going to do, let's plot our original figure first. So let's go to negative 2, 0, and that's a J. Then let's go over to up 4, that is our K. And then we'll do 8, 0, that is our L. And 2, negative 4, that is our M. Okay, now this is where you could use your ruler if you want to. You don't have to, as long as, try to get as straight up lines if you don't use a ruler. Okay, so you're going to plot that original figure and label all of the points, the vertices. Now, another thing I should have said is some people choose to do the graphs in 2 different colored pencils, or if you have colored pens. In one case, we have to do 3 figures on the same graph, so they use 3 colored pencils. If anyone wants colored pencils, I have some here that you could certainly choose from. as you're doing it, but you don't have to, okay? Now, what I'm going to do next is I'm gonna look at this figure over here, and I'm gonna specify what my new J prime is, okay? So again, what you're gonna do is you're gonna take -2 and multiply it by 0.75. And when you do that, that would be what? -1.5? Okay? Then you would take 0.75 times 0, which is just gonna be 0. Right? Now I'm gonna do K prime, and I'm gonna go 0.75 times 2, which would be 1.5. And then 0.75 times 4 would be 3. And again, you can use a calculator to figure these out if there's any that are tough. Then you'd go 0.75 times 8, which would be 6. And then 0.75 times 0 is 0. And then 0.75 times 2 would be 1.5. And 0.75 times a -4 is going to be -3, okay? Then I'm gonna come to my graph, and I have to graph those 4 points. And again, if you were doing 2 colors, this would be where you do your second color. So J prime would be -1.50. So really, this isn't gonna look, like much smaller, because 0.75 is not a huge reduction. K, and that I would label J prime. And then I would go K is 1.5 up 3, and that would be my K prime. And then L is over 6 at 0, so that is my L prime. And then M is 1.5 minus 3 down here, that is my M prime. And then you're gonna connect those 4. Okay? Now, when you're done, do not think that your distance between the 2 figures have to be equidistant or equal distance around. The reason is, like if you ever wanted to check your answers, how you could do it is just kind of think about, if I drew a line from here through K, would my distance from my origin to K prime be about 3/4 of the way? And then you could think of, if I drew from the origin to L, and then think about from the origin to L prime, is that about 3/4 of the way? And what it's gonna do is, the bigger your numbers that you're dilating, they're gonna be further apart. The smaller your numbers that you're dilating are gonna be closer. So don't think it has to be equidistant, okay? Now, let's go to this page, and we're gonna do the same thing, but this time we have a problem where our R is 3/2. Is that gonna be an enlargement or a reduction? Enlargement, because it's over 1. My rule, I always change the fraction to a decimal, so I'd put this as 1.5x and 1.5y. So that's another answer to our question, okay? Then I'm gonna copy down those points. So I use the Q, -1, -1, R is 0, 2, S is 2, 1. And then I have a new image for Q prime, R prime, and S prime. And what I'm gonna do in each of those is multiply by 1.5, okay, for every one of my coordinates. So for q prime, I would go -1 times 1.5, which is -1.5. And then I'd go 1.5 times -1 again, which is -1.5. Okay? For r, if I go 0 times 1.5, that's 0. 2 times 1.5 is 3. And then for s, 2 times 1.5 is 3. 1 times 1.5 is 1.5. So now I'm going to come over to my figure and I'm going to graph the pre-image first. So q is -1, -1. That is my q. And then r is 0, 2. That is my r. And s is 2, 1. So that is my s. So I have, that is my pre-image, okay? Now when I graph the image, q prime is -1.5, -1.5. So it's not gonna be a whole lot off from that when you have a smaller number, remember? The next one is 0, 3. And the next one is over 3 up 1.5. So this is your r prime, this is your s prime, and then this one is your q prime. And when you draw that new image, okay, again, do not be surprised if it has a bigger distance between on the sides that your coordinates are a little larger. You're not gonna have it where it's all equidistant unless your points are all equidistant from the center. Okay? Then, the last thing we're gonna do is something that has 2 dilations. So you can take your original figure, which is this blue, and in this case, they dilated it by enlarging it twice. But the examples that we do, we're gonna do the first dilation where we enlarge it, and then the second dilation, we're gonna shrink it down or reduce it. Or you could do that in opposite order too. One thing I want you to realize, when you do R, the first time you do a dilation, it's R prime. The second time you do it, it's R double prime. You could keep dilating something over and over again, but the most we do is 3. Okay? So your final question that we're gonna do, they give us 3 points, and we're gonna do 2 separate dilations. And again, our center is always the origin. So the first thing I'm gonna do is look at just my first dilation. If that's 1/2, am I enlarging or reducing? I'm reducing, right? And my rule, I would write that 1/2 as 0.5x and 0.5y. Okay, so that's another answer. Then I'm gonna copy down my original points. C is -7, -3. D is -7, 6. E is 1, 3. Okay. And right now I'm just dealing with that first dilation. So the first thing I'm gonna do is I'm gonna multiply all my coordinates by 1/2. So 1/2 of -7, so when I do C prime, that would be -3.5. 1/2 of -3 is -1.5. When I go to D prime, 1/2 of -7 again is -3.5. 1/2 of 6 is 3. When I go to E prime, 1/2 of 1 is 1/2. And 1/2 of 3 is 1.5. And I don't know why I put that as 1/2. You could certainly, but I'll just stay consistent and put that as 0.5. Okay? Now, let's do that one first. Let's graph our first figure and our new image, okay? So my first figure, when I go to do that, is at -7, -3, and that is my C. Then my D is at -7 up 6, that is my D. And my E is at 1, 3. Okay. So I'm gonna just try to draw as straight a lines as I can here. Okay. Then when I go to do my image, I'm gonna graph the 3 points here in purple. So C prime is -3.5, -1.5. Okay, that's my C prime. D prime is -3.5 up 3. And E prime is 1.5, 1.5 right here. And then I would connect those 3. Okay. Then my last figure that I'm gonna have to figure out is I have to do that second dilation. And by the way, the second dilation is with a scale factor or K of 2.5. So do you guys get 2.5 would be an enlargement? And then this would be 2.5x and 2.5y. Now, what do you guys think? Do you think I'd bring my pre-image down or this image down? Actually, you bring the image down. So it's like you have your pre-image, you do a dilation to that, and then you do a second dilation to your new figure, not the pre-image. Okay, so it goes in steps. So here's what happens. You're always gonna bring the points from your image down here to your pre-image. So C prime is gonna be -3.5, -1.5. D prime is -3.53. And E prime would be 0.5, 1.5, okay? Now, let's find our points of our image. And this time we're taking these and I'm multiplying by 2.5. So if I do -3.5 times 2.5, did you guys get -8.75? And this, you guys, you'd label C double prime, okay? Then if I go -1.5 times 2.5, that's -3.75. When I do my D double prime, -3.5 is -8.75. And 3 should be 7.5. Okay. Then 0.5 would be for E double prime. 0.5 times 2.5 should be 1.25 because that's half of it. And 1.5 times 2.5 is 3.75. Okay. So we already have the first two graphed. We don't graph the pre-image for this one because we already did. We just go to that next image, okay? So I'm gonna go over here and I'm gonna graph that last image. So the first one's -8.75, so almost to 9, down to -3.75. And that would be our C double prime. Then if we look at D prime, that's at -8.75 again, but it's up 7.5, okay? So it's that same almost 9, but it's up to 7.5, and that is our D double prime. And then if we look, our last one is 1.25, 3.75. So So just over 1 and up to almost 4. That is our E double prime. Okay, and now I'm going to connect those dots. So I have this line, I have this line, and I have this line. Does yours look like that too? And if you kind of wanted to think like, does this make sense? For the first figure, you're looking from the origin to D, and you're checking, does D prime look about half of that? And it does. For the last one, you're gonna look from 0 to your D prime, and you're gonna think from the origin to my D double prime, does that look 2.5 times that? So that's how you can kind of think about that. So I have a worksheet for you. The key is up here, and that is what you'll do. I think you have 6 problems. 2 of them have a composition where they have 2 of them. Did you think it was hard or easy? Okay. So like for geometry, there's like, I want to say like 18 to 20 something standards, and dilations are 2 of the 18 or 20 standards, which is really weird that it goes for that much of it.